Okay, today we will continue our chapter 3, logical reasoning. Okay, today we will look at learning standard 3.2.5, which is form a strong inductive argument of a certain situation. Okay, before you already know how to determine the strength of inductive argument. What means strong? Which is the conclusion is true. We also already learned about what is the form of inductive argument, which is from specific premises to general conclusion. Okay. A strong inductive argument is mean the conclusion must be true. Okay, it is the difference between the deductive argument. If deductive argument, we take a look for the validity. Okay, if the inductive argument, we take a look for the strength. Okay. First, before we enter on how to form the inductive argument, we take a look what is the example of inductive argument in daily life. Okay, like this one. This is the example. Premise 1. Eileen think Eileen is taking additional mathematics subject. Okay, this is specific premises. And then for the premise 2, Fatihah Nazwa is taking additional mathematics subject. Okay, this is also a specific premise. And then we can come out with the conclusion, which is the general conclusion that we can say that students of 4 elites are taking additional mathematics subject. Okay, this kind of inductive argument is we use as our daily life. This is the example. Okay, in daily life. Next, we jump into the example on how to form a strong inductive. There are two kind of question that usually come out, which is this kind of question for the number sequence. This is the first type, and the second type is the premises. Okay. First, we take a look for the number sequence first. So, the instruction: form a strong inductive conclusion for each of the following number sequence. Okay, example 1. This is the sequence. Okay, sequence. We can see that here is 1 per 1. 1 per 2, 1 per 3, 1 per 4, and dot. And then the example from the question, we have this kind of function. Yes, quadratic expression. Quadratic function. Yes, 1 per 1 is equal to 1 power of negative 1. Okay, this is the form of for 1 per 1. And then this one, 1 per 2 equal to 2 power of negative 1. And then 1 per 3 equal to 3 power of negative 1. And then for the last one is 1 per 4 equal to 4 per negative 1. Okay, to form a strong inductive conclusion, we just need to see the right hand side. Okay, the right hand side. We do not do for the left hand side, only for the right hand side, which is the 1 power of negative 1, 2 power of negative 1, 3 power of negative 1, 4 power of negative 1. Okay, for the first step to form the strong inductive conclusion is, first step, write down only the common feature. Okay, Remember, we must look at the right hand side only. Only this row, right hand side only. Write down only the common feature. Only the common. Okay. The common here is only the power of -1. Okay. 1, 2, 3, 4 is not a common feature because it's involving different number, which is 1, 2, 3, 4. Okay. The common is only the power of -1. And then we only we write down like this first. Okay. This is for the first step. And then for the second step, we replace the non-common with n. Okay, from this one, okay, we replace the non-common, the not common feature with n letter. Okay, with n, like this. And then for the third step, we determine the n. We determine what is n. From this quadratic function is, we know that n is 1, 2, 3 and 4. Okay, it must be in sequence. Okay, in order 1, 2, 3, 4. Okay, it cannot be 1, 5, 9. It must be 1, 2, 3, 4 and so on. It also can be start from 0, but from this example, it start from 1, 1, 2, 3, 4, and then you must put the 3 dots. Follow the question. Put the 3 dots. This is important. Okay, this is how you determine the n. And then for the final answer is in this form. Okay, n power of -1, and then n is equal to 1, 2, 3, 4 and so on, the 3 dots. Okay, this is the form of the final answer. Okay, this is the step to determine the strong inductive conclusion. Okay, this is the inductive conclusion in this kind of form. Okay, okay, do you can follow? Do you how to say? Dapat ikut tak?
Yes, teacher.
Okay, can. Okay, this is easy level. Now we upgrade our level to medium level. Okay, this is question 2. Example 2. Okay, sequence 99, 96, 91, 84, and 3 dots, dot. And then this is the quadratic function. 99 equal to 100 minus 1 bracket 1. And then second one, 96 equal to 100 minus 2 bracket 2. And the third one, 99 equal to 100. Oh, sorry, I think I make a mistake here. I changed my notes. Wait, here is 91, here is 84. Okay, okay, like this. Okay, this is the quadratic function. Okay, for the first step, just like example 1, we write down only the common feature. This is for the first step. What is the common feature? 100 and the minus signs. The difference is this one, 1, 2, 3, 4, and the number in the bracket 1, 2, 3, 4. And then already done with the first step, then we go to the second step. Replace the non-common with n. You can do n bracket n, but there is another way to replace the n bracket n, which is, we can see that from here, this is the perfect square number. 1 times 1 equal to 1 square. Okay, it's the same. 2 times 2 equal to 2 square. And then 3 times 3 is 3 square. Okay, same goes with the 4 times 4 equal to 4 square. From this, we can determine that this non-common is a perfect square number. Then we can replace this with n power of n, like this. Okay, the non-common we replace with n power of n, because from here this is perfect square number. And then for the third step, determine the n. N is 1, 2, 3, 4, and put the dot dot dot, 3 dots. Okay, and then the final answer, you just combine these two. Okay, this one and this one, so it will form the final answer. 100 minus n power of n, and n is equal to 1, 2, 3, 4 dot dot dot, 3 dot, not more than that, only 3 dots. Okay, okay everyone, do you have any question?
No, teacher.
No question. Okay, all of you understand on how to form the strong inductive conclusion? Is it okay?
Okay.
Okay, if I'm going too fast, just please stop me if I'm too fast. Okay, now for example 3. Okay, this is example 3. Sequence -5. Wait. -5, -2. Okay, third example. The sequence -5, -2, 7, and 22. Okay, this is the quadratic function. We only take a look at the right hand side only. Right hand side only. Okay, what is the first step?
Find church.
Find the common feature. Cari persamaan antara fungsi tersebut. The common feature. Okay, persamaan. Okay, this is the common feature. What is the common? 3. Okay, 3. And then the bracket different, and then we put blank in here because it is different. Then okay, the minus signs also common, sama. Then we put negative sign. 5 also common. Then we put 5. Okay, like this. This is the first step. And then we replace the non-common with n. But how? Okay, if we see from here, from the left, from the right hand side, is 0, 1, 4, 9. Okay, this number is not in orderly form. It's not like 0, 1, 2, 3, 4. Then we must come out with another way to make this in orderly form. Okay, just now we already see how to determine the perfect square number. Okay, from here, is this a perfect square number? 0, 1, 4, 9. It starts from 0. 0 power of 2. What is 0 power of 2? Hello?
0.
0. 0 power of 2 is 0. 1 power of 2?
1.
1. 2 power of 2?
4.
3 power of 2?
9.
9. So we are
9.
So we already determined in the orderly form. Okay, this is the perfect square number. Okay, from 0 to 3. Okay, 0 is the perfect square number for 0. 1 is the perfect square number for 1. 4 is the perfect square number for 2. And 9 is the perfect square number for 3. Then we already determined the orderly form of this one. 0, 1, 2, 3. Okay, like this. It is in the perfect square number. The common feature from this, okay, the red box one is the square power of 2. Okay, the common is power of 2. The only difference is 1, 2, 3, 4. And then we can write like this. 3 n power of 2 minus 5. N power of 2 is we get from here. N is the difference. The power of 2 is the common. Okay, like this. Okay, this is how you do the function. And then we determine the n. Okay, from this example, n is start from 0. Okay, so n is equal to 0, 1, 2, 3 and dot 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 3 dot. And then for the final answer, we combine these two, okay, to form the final answer. This one and this one. Okay, this is the final answer. 3n squared minus 5, and then n equal to 0, 1, 2, 3 dot dot dot. Okay, do you have any question? Semua dapat tak?
Dapat.
Okay.
Dapat.
Okay, now we continue. Okay, student practice. Okay, you do this by yourself. Okay, I already teach you step by step to form the inductive conclusion. Now I will give you 2 minutes to solve this question, and then we will discuss. Okay, you may start now. Okay, hi Daniel. Daniel, if you can hear me, please respond. Hi, okay. Please write your full name in the comment section. I already start the lesson. I want to nak ulang balik, tapi macam tak sempat. But you can follow us, continue the lesson. Okay. Okay. 2 minutes already passed. Now I will choose from all of you one person only by using this wheel picker. Okay, I will spin it by myself. Okay, you cannot spin it, I will spin it, and then I will choose. Please ready with your answer, and I will ask whoever that will be chosen. Okay, now I spin it. Okay, wait. I must close the background. Do you can see? Never mind, I spin it and then I will ask. Okay, the name that has been chosen is Nazatul. Okay, Nazatul, you can share your answer. Nazatul, where are you?
Oh, sorry, teacher. I just came back from the toilet.
Do you do this or not? Do you do this or not? Oh my god.
Yes.
Yes. Okay. What is your answer? First, write down only the common feature. Okay, what is the answer for this box?
N
This box, this first box.
N minus
This one, this box.
Oh,
The first box first. This one.
I went straight.
Or you went straight for the final answer?
I went straight to final answer.
Okay. If you went straight for the final answer, what is the final answer?
N cube minus square n plus 1 close bracket square, then n equals to 1, 2, 3, 4 and so on.
N cube minus n square, like that. How?
Yes. N cube minus bracket n plus 1 square.
Okay, that is your answer. N cube.
Then n.
Okay, then
n plus 1 square.
Then
equals to 1, 2, 3, 4 and so on.
N dot. The 3 dot. Okay, you must put down the 3 dots. Okay, now let's check is it the answer is correct or not. Okay, first step, write down only the common feature. Okay, the only common feature is the minus sign from this one, the bracket sign, the bracket sign, and then the plus sign, this one, the number 1 also common, and power of 2 is common. Okay, and then we replace the non-common with n, but first we must determine from here 1, 8, 37 and 64. Okay, this is the perfect cube number. Okay, first one is 1 cube. This 8 is equal to 2 cube. 27 is equal to 3 cube. Meanwhile, 64 is equal to 4 cube. Then we replace the n with n cube. Okay, n cube minus n plus 1 close bracket power of 2. Okay, this is correct. Okay, and then 3, determine the n. N is equal to 1, 2, 3, 4 dot dot dot, the 3 dots. Okay, so the final answer is we combine these two answers, then you get this answer as your inductive conclusion. N cube minus bracket n plus 1 close bracket power of 2, then n equal to 1, 2, 3, 4 dot dot dot. Okay, 3 dots. Okay, so your answer just now is correct. Okay, next, kebat
Yay.
Yay. You can tick your answer. And for those who get incorrect for this question, okay, please correct your answer. Okay, now we enter the kebat zone, which is the application of making a strong inductive conclusion in daily life situation. Okay, for example, okay, this is easy level. We start from easy to medium and the harder level. Okay, first, form a strong inductive conclusion based on the premises. Okay, this is the question 1. Premise 1, pigeons have feathers. Premise 2, eagles have feathers. So for the conclusion, we must come out strong inductive conclusion. We must make a strong inductive conclusion. Okay, so for the first step, the same as before, we must write down only the common feature. The common feature is have feather. Persamaan dekat argument ni adalah have feathers. Okay, write the common feature first, and then the second step, determine the category for the non-common feature. The non-common feature is pigeons, eagles. Okay, this is the non-common. Then we determine what is the category of these two, pigeon and eagle. Okay, tips. The category. Determine the category. What is the category? What is pigeon? What is eagle?
Bird, animal.
Animal? Your answer is animal, right? Is it correct?
Yes.
Animals. If you write,
No, bird.
okay. If you write animals, then you make conclusion animal have feathers. This is not true. So this inductive conclusion is weak. And then we narrow down the category with birds. Okay, just now you say birds. Pigeon and eagle is birds. Then we can say that this category is birds. Okay, then we write down the final answer. Birds have feathers. Okay, this is the strong inductive conclusion. Okay, this is the easy level only. Now we take a look for the medium level. Okay, question 2. Premise 1. Triangles are made of 3 straight lines. Premise 2. Quadrilaterals are made of 4 straight lines. Premise 3. Pentagons are made of 5 straight lines. And then we must come out with a strong inductive conclusion. Okay, for the tips, we must determine the category for the non-common feature. First, we must write down only the common feature. What is the common feature from these 3 premises? What is common feature?
are made of dot straight line.
Yes, are made of straight line. Okay, like this. Blank space are made of blank space straight line. Okay, this is the common feature from these three premises. And then we determine the category for the non-common feature. There are two non-common feature, which is the first one, triangle, quadrilaterals, and pentagon. All this is a shape, but what kind of shape? Okay, what is the category for these three? Triangle, quadrilateral, and pentagon. It starts with P. The category is start with P.
Polygon.
Yes, polygon. Okay, this is polygon. The category for this tree is polygon. And then we take a look for the second non-common feature, which is 3, 4, 5. Okay, what is the category for 3, 4, 5? What is the category? 3, 4, 5. Okay, this is number, but you cannot say number because it sounds weird. If you say number, so the conclusion will be polygons are made of number straight line. Okay, it sounds weird. You change the number with quantitative words. Okay, what is the quantitative word? Which is several. We change it with several. Okay, so the category for 3, 4, 5 is several. Okay, like this. Polygon for the first non-common feature. The second non-common feature is several. Okay, so for the final answer is polygon are made of several straight lines. Okay, this is the final answer. Okay, this is your exercise. This is the hard level. Saya sengaja je bagi hard level ni kepada kamu untuk kamu cuba buat. Dapat ke tak kamu jawab soalan kebat ni? Okay, hard level if you see from this question also, you will be pening-pening nak jawab. The unit of speed for particle, the unit of speed of cars, and then the unit of speed for airplane. You must determine what is the category for particles, cars, and airplane. You cannot say transportation because particle is not transportation, and then you must make another category. And then the other common feature is the meter, kilometer, and mile. What is the category for this one? And then the third one is the second hour. Okay, the premise 3 also hour. What is the category for this one? There are 3 non-common feature in this question. Okay, this will be your homework. Okay, you will do it by yourself, and then I will check your answer. Okay, now for the conclusion. Okay, conclusion, inductive reasoning can be carried out in the following step. Okay, we can come out with a flow map from how to determine the strong inductive conclusion. Ya Allah. Okay, this is the flow map. Okay, first observe some example or specific situation. First, before we answer before we make the conclusion, the inductive conclusion, we observe the premises. Okay, we observe the example or the specific situation, and then the second step, we observe the common feature. Okay, you must observe the common feature first, and then the last one, we can make a general conclusion, and the conclusion also must be true for us, for the conclusion to be strong inductive conclusion. Okay, now we already make conclusion. Okay, now this is task for today. That's why I say that today lesson is simple only. Okay, except for the KBAT one. Okay, I want to see if you can answer the KBAT question. Okay, now for task for today. Okay, first you must do exercise. Do the exercise in module activity workbook, page 43. Okay, and the second task, like usual, your understanding level. Case your vote based on understanding level in the Telegram poll. Okay, these two tasks for today. I will share this slide in your in Telegram, so you can write your notes. Okay, in your notebook. If can, please do not print this slide. Write your own notes in your notebook. Okay, kalau boleh jangan print slide ni. Kalau boleh kamu buat nota berdasarkan slide ni ke dalam buku nota kamu. Is it clear?
Yes.
Yes. Okay. Okay. Now we already reached the end of the lesson. Okay, please do the exercise in this slide. Only one question in this slide, which is the KBAT question, and then the task that I just said right now. Okay. That if you have any question, please ask me now. Do you have any question before we end the class? Do you have any confusion with the example that I have
No.
show you? So everyone understand all the questions, right? On how to do the strong inductive conclusion. Okay, no question. So that's all for today class, and thank you for joining Google Meet class for today. Please do not forget to do your exercise and case your vote in the Telegram. Please take care of yourself and stay safe. Okay, that's all for today. Thank you, and Asalamualaikum, and bye. You may leave this Google Meet right now.
Thank you. Teacher.
Alright,
Thank you,
you're welcome.
teacher.
Bye. 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 I will be sick.